Today we're going to be working with a recipe from the HPC Recipe Library on GitHub. If you want to understand more about the recipe library, have a look at this blog post which we'll link here. In a nutshell, the library contains a lot of compatible stacks that can pull together quite complex architectures. Since each stack is an example of infrastructure as code, these are building blocks that are ready to do most of the heavy lifting and fiddly configuration. You can use this to skip the learning curve when you're new to AWS, or if you just want to try something out quickly. Later on, you can dive into the bits of code and make any changes and all the changes that you need to make them your own. Now, today we're going to be working with a stack called the one-click AMD HPC stack. This, as the name implies, is a single stack that's going to launch an entire HPC cluster in one go. The cluster it builds will be using Amazon EC2 instances powered by AMD processors. The cluster itself is built using the AWS Parallel Computing Service. In 15 minutes when this comes online, you'll have a Slurm-based cluster with a login node for submitting jobs, a Lustre file system for superfast Scratch, a home file system on a very large and scalable NFS filer called the Amazon EFS, and then a couple of queues for submitting jobs. We'll explain all this in a few minutes. First, go to the page, click on the Launch Stack button, and then you just need to agree to these three important terms so that we can launch your cluster. In your CloudFormation console, you should have something that looks a lot like this.
You go to the name of the stack and you go to outputs. And this is basically the information about how you can log in. So the name of the ID for your cluster, links to the EC2 console, links to the Parallel Computing Service console,
and a link to an SSH key pair that we've automatically generated for you in case you want to use your own local shell to log into the cluster later. But for the rest of this tutorial, we're actually going to show you an easier way to log into the cluster without even needing to use a shell at all.
So go to the PCS console URL and let's just take a tour around the cluster. So this cluster is called Try AMD 9. As you can tell, I've launched 9 of these, so you will probably launch one. This is essentially the configuration for what you would think of as the head node. This head node is actually managed by AWS. You don't log into it or anything. We keep it going, we keep it up to date, we keep it running, and we do all sorts of scaling and other magic behind the scenes. We have some compute node groups. So there are 3 compute node groups. A compute node group is a pool of instances. They can be static, which means that they're always on, or they can be dynamic, which means they can scale from 0 up to n, where n is a maximum number. So one of these compute node groups is the login node group. This provides a static instance that we can use to log into the cluster. I'll show you that in just a second. The other 2 are C7A extra large and HPC 7A. If you're a regular account with some history of usage, you'll probably have enough service quota to use the C7A compute node groups. If you have never requested access to HPC 7A instances before, then you might actually need to go and do that in order to use the 7A 48 extra large compute node group. But the point is, this configuration has the capability to run compute jobs on both C7A kind of smaller instances as well as full like battleship class HPC 7A instances as well. So these are backed by queues. So basically the small queue submits to C7A, the large queue submits to HPC 7A. Yep, back to our stack. We want the EC2 console URL. This will actually take us to the running instance that is the login node for this instance.
And when we click on that, it takes us straight through to a thing called AWS Session Manager, which is brilliant because it is a web-based SSH connection through to the running instance without having to go out over the internet. It goes through a private, secure connection inside EC2 into the instance.
Yeah, when you log in, I will just mention you do log in as kind of a special session user. It's called SSM user. It's not super useful for this case. It doesn't know about Slurm. It doesn't know about a lot of things. It's just kind of a gateway account. So become EC2 user, and now just to prove it, this is actually a Slurm cluster. So there's 2 partitions, large and small. You can see that the nodes for large are HPC 7A. You can see the nodes for small are C7A. We could submit a job. We could do all sorts of other stuff. A couple of other features on this cluster. We look at the list of file systems. So the home file system, basically our home directory, has looks to like it has 8 exabytes of capacity.
And that's because it's using Amazon EFS, which is, in a way, a virtually unlimited NFS filer that is great for home directories. And yeah, it looks like it's 8 exabytes in scale, but you only pay for what you use. So it's actually one of those kinds of file systems.
We also have FSX. So this is a Lustre file system. This is mounted at /FSX. This has a lot of throughput capacity, limited size. Interesting thing about Lustre, you can go in to that Lustre, you can go into the console for that Lustre file system, and you can actually resize it on the fly. So you decide that 1.2 terabytes isn't enough to live with, you can go double it, triple it, quadruple it, etc.
And that's it. That's your cluster in a nutshell. You could do any number of things now. As Matt suggested, you could expand your Lustre file system if you didn't think that it was large enough or fast enough. You could have it mirror an Amazon S3 bucket where you have some large data set stored. Pretty cool. You can submit jobs to your Slurm partitions and watch in the EC2 console as Parallel Computing Service spins up nodes on the fly to meet the needs of the jobs in the queue. Now keep in mind, there's a few things that we've done to keep it all sane. We've configured these clusters to be small, so this exercise doesn't cost you much. So expect some small numbers of cores unless you decide to switch that up, which of course you can do. As we mentioned, you probably also need some special blessing to get access to the HPC 7A instances, since we really want to make sure that they're reserved for HPC customers, so they're access listed. Talk to your AWS account manager about that. But on the other queues, on the other Slurm queues, they shouldn't give you any issues. Go submit a job in there just for fun. There's a lot of helpful information in the README file in the Git repo. I'll leave the short URL here. That's it. Go have some fun. And remember, it's totally okay to mess around and break things with this. You're only ever 15 minutes away from recovering a pristine environment. This is the best way to learn something new. And when you're done, go back to the CloudFormation console and delete the top level stack. That's the one called Try AMD or whatever you named it. Everything in there will just collapse into a wisp of gas and go away, leaving nothing more than some entropy and hopefully some new confidence that this stuff isn't hard. The stuff you use it for is, and that's why we're in HPC.